Greetings from EarthLab. Today let's talk about life cycle assessment. Life cycle assessment, or LCA, is a systematic process for evaluating the environmental impacts associated with the product, process, or service throughout its entire life cycle. The goal of life cycle assessment is to identify and quantify the energy and materials used and the waste released to the environment. This comprehensive assessment helps in understanding the overall environmental footprint of a product, allowing for more informed decision-making. This process got 4 main stages as goal and scope definition, life cycle inventory, life cycle impact assessment, and interpretation. Let's look at each step in details. First, goal and scope definition. Goal defines the purpose of the LCA, such as comparing products, identifying hotspots for improvement, or informing policy decisions. Scope specifies the boundaries of the study, including the functional unit, for example, 1 kilogram of product, the system boundaries, which processes are included, and the level of detail. 2. Life cycle inventory, LCI. Data collection involves gathering data on all inputs, raw materials, energy, and outputs, emissions, waste, for each stage of the product life cycle. Quantification quantifies the material and energy flows into and out of the system being studied. This includes extraction, production, transportation, use, and disposal stages. 3. Life cycle impact assessment, LCI. Classification assigns the inventory data to various environmental impact categories such as global warming potential, acidification, eutrophication, etc. Characterization converts inventory data into potential environmental impacts. For example, CO2 emissions are converted into global warming potential. Normalization and weighting, optional, places the impacts into a common context and applies weights to reflect their relative importance. Or, interpretation identifies significant issues, highlights the major contributors to environmental impacts, evaluate findings, assesses the completeness, sensitivity, and consistency of the results. Conclusions and recommendations provides actionable insights based on the LCA results, such as suggesting design changes, material substitutions, or process improvements. Here are the applications of life cycle assessment. Product development and improvement, identifying opportunities to improve the environmental performance of products at various stages. Strategic planning, assisting companies in strategic decision-making and setting environmental priorities. Policy making, informing policymakers in developing regulations and standards. Marketing and communication, providing credible information on the environmental performance of products, which can be used for marketing purposes. Benefits of doing a life cycle assessment. Holistic view considers the entire life cycle of a product, from cradle to grave. Informed decision-making provides data-driven insights for improving environmental performance. Regulatory compliance helps meet environmental regulations and standards. Competitive advantage enhances sustainability credentials and marketability of products. Challenges of life cycle assessment. Data intensity requires extensive and detailed data, which can be difficult to obtain. Complexity involves complex modeling and analysis, requiring expertise in environmental science and engineering. Variability. Results can vary depending on the assumptions and methodologies used. Just like that, life cycle assessment is a valuable tool for understanding and mitigating the environmental impacts of products and processes. By considering the entire life cycle, LCA helps to identify the most significant areas for improvement and supports the development of more sustainable products and practices. Thank you for watching. Let's meet with another interesting video again.